Signal timing tutorial using Econolite controllers. The arterial is a segment on Imperial Highway in Yorba Linda, California, which has 9 signals. Let's use the intersection of Imperial Highway, Yorba Linda Boulevard as an example, which is located at the south end of the corridor. Similar to any other signal controller software, the first step is to get the key signal timing parameters from the timing sheets, which includes cycle length, offset, and its reference point, phase sequence, and phase splits. We will use the weekday PM plan as an example. From the schedule, day plan 1 runs on weekdays, and the PM plan corresponds to action or pattern 13, which runs from 3 p.m. to 7 p.m. Find the coordination pattern 13 table, where you can get the cycle length, offset, phase sequence, and splits. You can also see which are the coordinated phases. The sequence code for this PM plan is 13, which is defined in the controller sequence table. Offset reference is lead, which is also called TS2 first green. The other basic timing parameters, such as walk, pedestrian clearance, yellow, and red clearance, can be found in the controller timing plan table. In a signal retiming project, these parameters usually are not touched. Based on the key parameters found from the timing sheets, code them in WaveSync, and this is how it looks like. Cycle length is 130 seconds. Offset is 28. Coordinated phases are phases 2 and 5, and the reference point is TS2 first green. The phase splits as well as the phase sequence are shown at the bottom. Code the remaining signals, create a subsystem, and then view the time-space diagram for the PM plan. Using the virtual trajectory function, you can see that the northbound will have at least one stop at the Valley View intersection. The southbound direction looks pretty good. Big data were available to allow us to pull out many trajectories and lay them over the time-space diagram, based on which signal timing performance measures can be generated. Notice the one major stop at the Valley View intersection. The quality of signal timing performance index indicates an overall level of B+, but the northbound has a level of B. Now we can perform a quick bandwidth optimization. In order to not affect the major crossing arterial Yorba Linda Boulevard, we need to fix the offset and sequence at the common intersection, which is at the south end. The optimization yielded very good bandwidth for both directions, but perhaps a minor offset adjustment at the north end signal could be done depending on your preference. The new timing plan, which only involves in changes of offset and phase sequence at some signals, is ready to implement and fine-tuning. As can be seen from the floating car run trajectories, the northbound stop at the Valley View intersection is essentially eliminated. The quality of signal timing index is now A in both directions. Now let's watch a side-by-side comparison of the floating car runs for the before and after timing plans. The new timing plan was able to reduce the northbound travel time by 31%. Thank you for watching.